In this video, we're going to talk about writing a specification for a whole program, not just for individual methods. I'm going to talk more about how we can break a problem down into smaller and smaller problems. And I'm also going to solve a burning question that I have: how much can I save on my mortgage payments if I pay the principal down early? You know, we write computer programs in order to solve problems, right? Some customer out there has a problem, we write a program to solve it. And so here we are at the end of this course. I want to write a program that actually solves a real problem that I actually have. Right. So let's start talking about the business domain of this problem. In case you are one of the lucky people who does not have a mortgage, let me explain to you how this works. So there's the principal, which is the amount that is owed by me, the borrower, to the bank. There's the interest rate, and that's a percentage of the principal paid as a fee to the bank. Now, it's typically quoted as an annual rate, but the interest is typically paid off monthly, right? So there's a monthly payment. It's paid by the borrower to the bank. That covers 1 month's worth of the interest. Any extra left over after the interest is paid reduces the principal by a certain amount, right? So if you start off owing $100,000 and you have just to make the math easy, you have a 10% rate of interest, right? Then you're going to be paying off roughly 1% of that interest every month, right? So about $1,000. If you pay more than $1,000, right, then the $1,000 pays off the interest, and anything extra pays down the principal, so that the next month the interest is a little bit smaller, right, because the principal is a little bit smaller, right? So if you can pay off a larger and larger amount every month, right, then you can reduce the principal faster and faster, which means that you pay less and less interest over time, right? So let's write a specification. You know, so far we've only been writing specifications for methods, but I want to talk about what's the purpose of this program, right? We're not going to talk about this at the level of of method inputs and outputs. We're going to talk about the whole thing. Well, I'll start with a very vague specification. I always like to start with something vague and short. So the program, it's going to tell me how much I'm going to save and how much faster I'm going to pay off my mortgage if I pay off extra each month, right? OK, well, that's pretty vague. Can we make that slightly less vague? The program is going to ask me some questions. It's going to ask me, what's the current principal that I have? What is the amount that I owe the bank right now? What's the current interest rate? So how much am I paying the bank as a percentage every year? And what am I currently paying every month, right? And then some portion of that will go to the interest, some will go to principal. Over time, the portion that goes to interest gets smaller and smaller as the principal gets smaller and smaller. And then it will display for a variety of possible extra payment levels, the amount of interest I'm going to save over the lifetime of the loan, and how the payoff date is going to change. Obviously, if I pay off more and more every month, then the loan gets paid off earlier and earlier, right? So I'm not sure how I'm going to solve this, right? Now, several times in this course, I have said that there's an easier problem. Start by solving an easier problem. And I'm actually quoting one of my favorite mathematicians, George Polya, born in 1887, died in 1985. He was very old when he died. And he famously said, if there is a problem you can't solve, then there is an easier problem that you can solve. Find it. Right? And his idea was, of course, that by solving the easier problem, you will get insights into how to solve the harder problem, or you will get a tool that allows you to solve the harder problem. He actually wrote a whole book about this. It's called How to Solve It, and it's really good. It really helps mathematics students at pretty much every level. And there are also versions of How to Solve It for other disciplines as well, I think including computer programming. So anyway, let's find a simpler problem. We've already seen in a previous video how to prompt the user for a value. We've seen how to convert that value into an integer. We can probably figure out how to convert that value into a decimal. We're dealing here not with a physics problem, but with a money problem. So we should probably continue to work in decimals. So let's just start there, right? Let's write some code. I'm going to just create a main method here, and I'm going to say, please enter the current principal. We're going to read the the line from the console into this principal text string. You remember that text that we read from the console is always in the form of a string. I need to get that into a decimal. So I'm then going to say decimal.tryparse, just like we did int.tryparse. Decimal.tryparse takes the text. It takes an out parameter, a variable that it's going to write the value into, and then it returns whether it succeeded or failed. Now, it seems pretty clear what we're going to do on success, right? We're going to continue to then ask the question, well, what's your interest rate? What's your monthly payment? And so on. But we don't know what we're going to do on failure. So let's go back to our specification. And we need to update the specification because it was too vague before, right? So let's just talk about the inputs here. The program's going to request the principal and the interest rate and the monthly payment. If an invalid value is entered, then an error message is displayed, and the user is prompted to try again. OK, so now our specification is saying what to do in the event that the user does something unexpected, which is good. You always want to, as my Uncle David constantly reminds me, expect the unexpected. All right, well, we know how to do that. Let's see what we can do here. All right, so I've rewritten this code here. We have a while loop. It loops forever. The condition is always true, so we should expect that somewhere in here there will be a break that breaks out of the loop. So what are we going to do? Well, we're going to say, please enter the current principal. All right, so we've met our specification. We've prompted the user politely. We're going to read the text into this variable. Then we're going to convert that into a decimal, store the result in the principal variable. If we did not succeed, then we are going to prompt the user to try again. We'll say, please enter a decimal value. Remember, this is not success. If not success, then say, please enter a decimal value. Right? What are we going to do if we write this out? Well, we're going to skip the alternative. We're going to fall to the bottom of the loop. And what does a while loop do? It keeps on running until the condition is false. The condition is always true, right? So it's going to run the loop again. It's going to say, please enter the current principal. We're going to keep on trying again. If we get success, then not success is going to be false. Therefore, we're going to take the alternative. Therefore, we're going to break out of the loop, right? So let's try this. Right? We can actually step into this code and see how it goes. I'm going to put a breakpoint right here. All right, so we could say, please enter the current principal. And if I type nothing, then it says, please enter a decimal value. If I type some nonsense, it says, please enter a decimal value. So I need to enter a decimal value. Negative 123.5 is a decimal value. And we get back in here, we can see, yes, the principal is negative 123.5. Right? So once again, we have demonstrated that users do the darndest things. Right? We need to go back to our specification and say, you know what? We also need to figure out what to do if this thing is negative, right? So we said here, if an invalid value is entered, then an error message is displayed. We never clearly defined what an invalid value is. Right? So we should say, well, a negative value is also an invalid value. All right, well, how on earth are we going to do that? I've rewritten this code again. This time so that it can handle what happens if a negative value comes in. So let's go through this. We've got our while loop, as we did before. So we will loop until we hit the break condition. We write out, please enter the current principal. Right? If somebody types in a number that is, if somebody types in some text that is not a number, then we say, please enter a decimal value. Otherwise, if they typed in something that we succeeded at parsing it as a decimal, but it was negative, if it was less than 0, right, then we say, please enter a positive value. And then we loop back around again. Right? If these conditions are both not met, if we did succeed and the principal was greater than or equal to 0, right, then we break out of this thing. All right. So it looks like this probably should work. We'll put a breakpoint right here and give that a try. All right, so we'll enter the current principal. I'll try entering nothing. No, it says, please enter a decimal value. I'll try a negative value. It says, please enter a positive value. We'll try a positive value. And that worked. Right, we have broken in the debugger. The principal is 123.0. All right, so that seems pretty straightforward. We have now solved this problem for the principal. So so now we need to do it for the interest, right? So what are we going to do? Well, we probably want to just take all of this code and hit Control-C to copy it, and Control-V down here, and then we'll change this to interest. Wait, what am I doing? No, this is terrible. Do not do this. Do not copy-paste large chunks of code before you think about what you're doing. We have some task that we want to perform here, right? We want to take in a number. We want to validate that it is a valid number and that it is positive. If it is not, then we want to prompt the user to keep on entering it. We want to do that 3 times, right? Once for the principal, once for the interest, and once for the monthly payment. It seems sensible that we would want a method to do this, right? Well, all right, then let's write a specification for that method. So now we're no longer looking at the program specification. Now we're going to specify a specific method. What's the purpose of this method? This method repeatedly prompts the user until a valid positive or 0 decimal is entered. So it has to be non-negative. It's a little bit weird to say my interest rate is 0, but that's legal. A bank could have a 0 interest rate. So we should probably allow 0 entries. What are we going to call this thing? We'll call it read positive decimal. Really, maybe we should call it read non-negative decimal, but I'm not going to stress the point, right? What's the input? The input is the string that we are going to write out to the user because we want to be able to say, enter your interest rate, enter your principal, enter your monthly payment. What are the outputs? They're a positive decimal value. What are the side effects? Well, the side effects is this thing prints to the console and it reads from the standard input, right? All right, so we have a method specification. So let's write this method. So I'm back in Visual Studio here, and I have this block of code, and I would like to have a method that has the action of this block of code, right? That has this loop that keeps on prompting the user until they enter a positive decimal, and so on. Now I could just create a method that matches the specification that I just wrote up. But I'm going to show you a super powerful technique in Visual Studio. So I'm going to select this block of code. I'm going to right-click on it. I'm going to choose Quick Actions. And you see down here, it says Extract Method. And now it is displaying to me, suppose you were to take this code and make a method that has just this code in it. What would it look like? Well, this is what it would look like. It would be private, static, void. It would be called new method because Visual Studio doesn't know what I want to call it. And then it would have this text in it. And if that looks good to me, then I'm just going to click on Extract Method. All of that code has now been moved to its own method, right? So and this has been highlighted in green. So if I now type in read positive decimal, right, then the method will be renamed read positive decimal. I can highlight that, hit F12, and go to it. And Visual Studio has automatically generated for me a private, static, void method called read positive decimal. The private, we have not talked about code accessibility in this course. We're not going to. I'm just going to delete the private. All right, but we have this method read positive decimal, and what does it do? Well, it creates a decimal called principal, and then it has this loop. It doesn't return anything. We would like this thing to return something, so I'm going to change this void to decimal, right? And now we get a red squiggly under this saying, well, hey, this thing does not return anything. Right? Well, what do I want to return? I want to return the principal. All right. I also said that I wanted this method to take a prompt. All right. And so I'm going to change this console.writeLine to console.writeLine prompt. All right, so now let's take a look at what this thing does. We have a method, it's static, it returns a decimal. It reads a positive decimal, it takes a prompt as a string. So far, it's exactly matching our specification. We have a decimal called principal. We go through the loop, we write out the prompt, and so on. We read the value in, we try to parse it. If it doesn't succeed, we say, please enter a decimal value, or please enter a positive value. Otherwise, we break and return the principal. We actually don't have to break here. I could just say return principal right here, because what are we going to do? We're going to pop out of the loop, and when we hit the break and then just return it. Well, why even do that? Just say we're going to run until we return the principal. And as we know, if you hit a return statement while you're inside a loop, the loop stops dead in its tracks, and we just go back to the caller. Right? Is there anything wrong with this method still after this, this extract method refactoring, this is called? Yes, there is. This variable no longer makes sense to be called principal, right? Because we're now going to use this thing to read the principal, the interest rate, and the monthly payment. So let's just call this thing result. So I'm going to show you another powerful technique that we can use to fix the problem that this principal variable now has the wrong name. I'm going to double click on it, highlight it. You notice that when I double clicked on it, everywhere that it was used has now been highlighted in gray. So this is a really useful tool if you want to figure out, oh, what are all the places where this local variable is going to be used. And then I'm going to hit the magic key sequence, Control-R, Control-R. These all suddenly become highlighted in green. And now if I change the name here to result, you'll notice they all change. Right? So this is a pretty slick way to rename your variables. If I hit escape, then it goes away. Right. So I'll do that again. OK, there, I'm done. So now I've got my result variable. And when I hit enter, that commits the change. All right, so now I have my method. Right? What am I going to do with it here? Well, when we extracted the method before, it made me a call to read positive decimal, right, where the code was originally. But of course, now we've changed the signature of read positive decimal. If we hover over this thing, it says, there is no argument given that corresponds to the required formal parameter prompt of read positive decimal. And it notes here, well, read positive decimal takes a string, right? We are expecting a prompt to be passed in. We're not passing one in, so we're going to need to do that. Well, so let's do that. All right. So we now have our calls to read positive decimal for the principal, the interest rate, and the monthly payment. We pass in our prompts saying, please enter the principal, please enter the interest rate, please enter the monthly payment. Let's try this out. Let's see if it works. Put a breakpoint there. We'll hit run. So I'll say enter the principal. I'll say $100,000. I'll enter the interest rate. Let's say 5.5%. I'll enter the monthly payment. Oh, I forgot to enter a decimal value. It'll prompt me to enter the monthly payment again, negative $30. Oh, no, it requires me to enter a positive value. I'll enter $3,000. Well, that's a pretty steep monthly payment. All right, we hit our breakpoint here. And what have we got? We've got the principal, $100,000. The interest rate, 5.5, the monthly payment, $3,000. So you notice how much more clean this code looks, right, than that mass of code before with all of the loops and the breaks and the whiles and all of that, right? What does this code do? It reads 3 positive decimals with this prompt. Right? So this is the real power of method abstraction here. Right? You want to make your code match the specification as closely as possible. And one of the great ways to do that is to say, every sort of sub-problem that I have, I'm going to make a method for that, have the method solve that problem in the cleanest, smoothest, easiest possible way. And then I'm going to use that abstraction to write my code so that the code is understandable. Right? Very clear what this code does. It would be much less clear if we had those 15 or 20 line code segments cut and paste 3 times to make it 60 lines long and a lot of duplication. All right. So now that we have solved the first part of our problem, right? Our program specification says you ask the user to enter the principal and the interest rate and the monthly payment, and then you compute how much interest they are going to save given a variety of different options for increasing the monthly payment. All right, well, that's totally vague, and I don't know how to solve that problem. Right? So again, I'm going to go back to Polya's basic principle of there's a problem, I don't know how to solve it. There is an easier problem that I do know how to solve. I'm going to solve that. Right? So the easier problem that I'm going to solve is I'm going to say, well, suppose I have the principal, the interest rate, and the monthly payment. How much interest do I even pay over the lifetime of this loan? Right? So let's see if we can solve that easier problem, and then we'll come back to the harder problem of how much interest do I save given different options later. All right, so I want another method, right? We have methods now to do the first part of the problem, to read in the principal and the interest rate and the monthly payment. I now want to solve the simpler problem of what's the total interest that I'm going to pay on this loan over the lifetime, given those three quantities, right? So that sounds like a good job for a method. I'm going to call my method total interest. What are its inputs? The inputs are those three values. What are its outputs? A decimal value, that is the total interest paid over the lifetime of the loan. The inputs have to be positive numbers. We know that. No side effects. All right, so let's take a look at how we might write a method like that. All right, so I've written up a bunch of code here. We've got a static method. It returns a decimal. It's called total interest. And it takes our three principal and interest rate and monthly payment values as parameters. Right? The first thing we're going to do is we're going to, of course, check to make sure that the error conditions, the preconditions, are met. Right? So we'll say, well, if the principal is less than 0, then throw an argument exception that says the principal must be positive. And I always like to double check, because as we've seen, this is a bit of a candy machine interface. In fact, yes, the message goes first and then the parameter name. All right, the interest rate, similarly, less than or equal to 0. The monthly payment, less than or equal to 0. If any of these conditions are true, then we're going to throw the appropriate argument exception. Right? All right, so how are we going to solve this problem? Well, we're going to simulate what happens at the bank as I pay things off. Right? So every month there's going to be a payment, right? This monthly payment value right here. And that is going to reduce the principal, and it's going to pay some interest. Right? And that is going to repeat until the principal is gone. We're going to keep track of the total amount of interest paid so far. So let's make a bunch of variables that represent these different concepts. The total interest will be represented by a decimal called total interest. We're going to start that off at 0. Right? Clearly, that's the right thing to do. We're going to be accumulating a bunch of interest payments starting at 0, and we will just keep on adding on to that. We're also going to keep track of the current principal. You remember from a previous video, I said you don't ever want to change the parameter. You don't want to treat the parameter as a variable. We could say, oh, well, this principal, it starts off as the current principal, and then we're going to change it every time we go through the loop. But I find that very confusing to change the value of a passed-in parameter. So I'm going to make a new variable. Variables are cheap. You can make as many of them as you want. I'm going to call it current principal. And again, I want the variable to represent the quantity that I am sort of semantically trying to capture in this program. I'm trying to capture the idea of what is the current principal as we're moving through time. All right. So we're going to keep on doing this operation until the principal becomes 0 or less than 0. Right? Well, because we might have a case where, for instance, the principal is 100, the monthly payment is 1,000. We don't want to say, oh, well, the monthly payment has to reduce it exactly to 0. If the monthly payment is 1,000, then the principal will be reduced to negative 900 in our program. We don't need to worry about that edge condition. So we'll just check to see if it is 0 or less than 0. So while the current principal is greater than 0, what are we going to do? We're going to keep on executing this block of code. So it works out the current interest payment. The current interest payment is the principal multiplied by the interest rate. So how much is the principal going to be reduced by? Well, it's going to be reduced by the monthly payment minus the amount that went to interest. Right? So how is the principal going to change? Well, the new current principal is going to become the old current principal minus the reduction. And the total interest is going to be the total interest plus the current interest. All right, and then when we get out of this loop, we are going to return the total interest. All right, so this seems pretty straightforward. So I've written up this method. And we've got to have a call to it. So I've also written up a call to the method up here. So we read in our 3 values, we pass them off to the total interest method, and we should see what we get back. All right. So let's try running this code and just see what happens. Right. All right, so our console window opens up. Let's enter the principal. Let's just keep the math nice and easy. We'll say that we owe $100,000. Right? And what's the interest rate? Let's say that it's 5%. And what's the monthly payment? Well, let's say that we are paying off. It's a pretty high monthly payment. Let's say that we're paying off $2,000 a month. Right? What's going to happen here? Right? Oh my goodness. We got an overflow exception was unhandled. What on earth happened here? Take a look at the value that is in total interest. This is far more than trillions of dollars. This is trillions of dollars. And the C# is telling you here, you tried to compute a decimal that was so large, I can't even represent it. And remember, decimals can represent numbers that are up to just about 10 to the 28. That's a really huge number. So something must be going deeply, deeply wrong here. Well, let's see if we can figure it out. I'm going to put a breakpoint right here. And we're going to start this program again. We'll put in those values again, see if we can figure out what's going wrong. All right, so we'll enter the principal. That's $100,000. And the interest rate was 5. And we said the monthly payment was $2,000. All right, we've hit our breakpoint. So let's see what's happening here. Our total interest is $0. Right? The current principal is $100,000. I'm going to make this a little bit bigger here. And now we're going to go into this while loop here. All right. So the current interest is the current principal times the interest rate. So the current interest is $500,000. OK, clearly this is wrong. What have I done here? Oh, I said the current principal multiplied by the interest rate, but I forgot that the interest rate is a percentage. All right, well, let's divide that by 100. All right, so, well, glad we noticed that. So let's try that again. I'll start this program over again. So we'll enter the principal, $100,000. The interest rate is 5. The monthly payment is $2,000. All right, so the total interest starts off as 0. Current principal is $100,000. All right, the current interest is, wait, $5,000? We're paying $5,000 interest. But so how much are we going to reduce our principal by? Negative $3,000. So the principal is going to go up by $3,000. What have we done wrong here? Oh, the interest rate, we are computing a year's worth of interest every month, right? This should be divided by 1,200. All right, well, what's really going on here? What's really going on here is I am typing faster than I am thinking, right? And this is how bugs get into programs, right? You're just typing along and you're like, OK, the principal times the interest rate is the current interest, and not stopping to think, well, wait a minute, that's a percentage. And this is going to be monthly and not yearly, and so on, right? So if we'd had unit tests, right, for this method, particularly if we'd done some kind of test-driven development thing where we had written the unit tests first, we would have found this problem very, very early instead of having to kind of find it by trial and error and by inspecting the code and trying to figure out what's going on. So once again, we have seen the value of writing good tests for a method and not just kind of going ahead and writing the method willy-nilly. All right, so this is now correct, but this illustrates another problem, right? Essentially the problem here was we were computing far too high a monthly payment, and therefore when we were doing the subtraction, we were getting a negative number. But that's still possible, right? Let's try this code again, right? We'll enter the principal of $100,000. And this time, we'll say that the interest rate is 5 once again, but we'll say that the monthly payment is $10. I'm gonna pay my mortgage off at $10 a month, right? So now we entered the loop here. Right? The current principal is $100,000. The interest for this month is $416.67. This is actually correct now, so that's good. But the problem is that the reduction is still negative, right? So once again, the principal is going to go up, right? And the interest is going to get larger and larger and larger and larger because the loan is never going to get paid off. And eventually, this program is going to crash, saying you tried to add a value to a decimal that was larger than the largest possible decimal. All right, so how are we going to fix this problem? Let's go back to the beginning of our program once again. Right? Well, so we've got the principal, we've got the interest rate, we've got the monthly payment. It's possible that no one of these things is wrong, but all of them working together are wrong. You know, if all of them are such that the interest rate you would pay in a given month, the amount of interest that you would pay in a given month, is smaller than the monthly payment, then this program is going to crash and die. And we need to prevent that because it's entirely possible that a user will type something like that in. I just did. How are we going to fix it? Well, our specification doesn't really tell us anything. No one of these data are wrong, right? So I really don't know what to do. This illustrates why developing software is so hard. You know, there are lots of situations like this all the time where it's not at all clear what the specification says to do. It's not at all clear what the user wants us to do. Right? We could say that when we get to the monthly payment, if the user types in a monthly payment that does not jibe with the principal and the interest rate, that they have to enter the monthly payment in again. But what if the thing that they entered wrong was the interest rate? Or what if the thing they entered wrong was the principal? It's hard to say what the right thing to do is. So I'm going to say, just kind of arbitrarily, let's say that we are going to repeat the process, the whole process of saying what's the principal, what's the interest rate, what's the monthly payment. We're going to keep on repeating that until we are at a point where all of those things match, right? Where the principal and the interest rate give us a value that is paid in interest every month that is less than the monthly payment. All right, so how are we going to fix this problem? I'm going to put the whole thing in a loop, and we're going to keep on looping around until we get a value that satisfies us. So I'm going to start by declaring these 3 variables outside the loop. All right, then we'll make a loop here. We're going to loop forever until we hit a break statement. All right, and then we are going to read the principal, read the interest rate, read the monthly payment. And then I'm going to say, if the principal multiplied by the interest rate divided by 1,200 is less than the monthly payment, so if the amount that I'm going to pay in interest in the first month is less than the monthly payment, then break out of this loop, right? We have satisfied that condition. Otherwise, if we don't break out of the loop, I'm going to say the monthly payment does not cover the interest. And then we're going to end this loop here. All right, so let's try this. Let's see what happens. Now, do you see why I had to pull these out of the loop? Right? If these were declared in the loop, then they would be scoped to this block, which would mean that I could not use them in this computation of the total interest. Right? All right, so we'll step into that. We'll see what happens. All right, so we'll read the principal. And I'll enter $100,000. We'll read the interest rate. Say 5%. We'll read the monthly payment. I'll say $20. And now the principal multiplied by the interest rate divided by 1,200 was not less than the monthly payment. So we skip the break, and we say, right, the monthly payment does not cover the interest. We go back around, enter the loop again, right? And now we have to type them all in again. OK, so this seems to be pretty good. Can we make it even better? Yes, we can. I'm going to highlight this, hit F12 to go to total interest. So we could also add a condition down here. We could say that it's a precondition. We could say that if the principal times the interest rate divided by 1,200 is greater than or equal to the monthly payment, then throw a new argument exception, and so on, right? Monthly payment does not cover interest. All right. Is there anything else we could do to improve this? Yes, there is. The problem arose when the reduction of the principal became negative, right? So I could say, I now believe that I have fixed this program so that the reduction will always be positive. And so if I actually believe that, I should assert it, right? I'm going to say debug assert reduction is greater than 0. All right, so now if we are testing this program and the assertion ever fires, then I will know I have a bug here somewhere. I have somehow allowed the reduction to become greater than or equal to 0. I said before that we were done the first part, right? The take in all of the input and verify it, and I was wrong. Right? We needed to come back and add another loop around that thing to really verify that the input was correct. But now it looks like we are genuinely done with the first part of this program. We can take in the principal, we can take in the monthly payment, we can take in the interest rate, we can compute the total interest paid, which remember is not exactly what we're looking for, but this is a problem, an easier problem that we want to solve along the way. Now, if we go back to our specification slide, we saw that it said in the second part here, it displays for a variety of possible extra payment levels the amount of interest saved and the payoff date. So we're also going to need to figure out not just how much interest is paid here, but how much time is it going to take to pay off that interest, right? Now, we don't know how to solve that problem yet. But once again, I'm going to say, I don't know how to solve that problem. I do know how to solve a simpler problem. And that problem is, how much time is it going to take to pay off this mortgage, given this monthly payment and this interest rate? So let's see if we can solve that problem. I'm going to create a specification for yet another new method. What's the purpose of this method? Well, it's going to compute the number of months required to pay off a loan, given the principal, the interest rate, and the monthly payment as decimals. I'm going to call it payoff months, because that seems like a sensible name. The inputs are the same, the 3 decimals that we've been working with this whole time. The output is going to be an integer number of months that it's going to take to pay this thing off, right? And the inputs have to be positive. And we should probably also add a note to this thing that says that the inputs must be such that the monthly payment covers the interest. I've written up a bunch of code that does that. It looks remarkably similar to the code that computes the total interest. So we begin here by saying, let's make sure that the principal and the interest rate and the monthly payment and so on meet all of the conditions that we expect them to. Then we say we have a total number of months. This is analogous to the total interest paid so far. And we go through the same loop as we did before. We have the same assertion as we did before. This time we just add 1 to the total number of months. Right? Now you might say, this code is structurally extremely similar to the code that we had that computed the interest. Is there anything that we can do to reduce the amount of code duplication here? Right? A lot of times I've said if you're cutting and pasting code from place to place and making minor changes, then probably there is some more fundamental thing that we could be doing here to make the code simpler. And there is. And those techniques we are not going to cover in this course. There are techniques where you can say either, I'm going to have a method that returns 2 values. It returns both the amount of interest paid and the number of months it took to pay it. Right? Or we could have a method that has this sort of general structure, but the accumulation, right, the fact that we are accumulating the number of months or that we are accumulating the total interest is also a parameter to the method. Those are pretty advanced techniques. They're out of scope for this course, but I just wanted to point out that were we writing this code for some professional quality library of financial tools, we might want to use a technique like that in order to reduce the amount of code duplication. All right, so we now have methods that we can use to get the principal, the interest rate, and the monthly payment read in from the console. We have a method that will compute the total interest of this loan, and we have a method that will compute how long this loan will take. Let's just run a quick test of those things and make sure that the values are sensible. So I'm going to say, so we want to find out whether this does what we intend it to. So let's say that we're going to compute the total interest. We'll also say the payoff months is equal to call to our method, payoff months with the principal, the interest rate, and the monthly payment. And let's just see what this does. We'll just hit go. And we'll enter the principal. Again, let's say I've got a $100,000 mortgage at a 5% interest rate, and I'm paying it off at $2,000 a month. We'll clear that breakpoint, hit go. The total interest was computed at $12,369 and change. Remember, decimals are accurate to 29 or so decimal places, so this is way more precision than you would ever actually use. And the payoff months, I would pay this thing off in 50 months at that rate. So that's pretty quick. All right, so the method specification said that we're going to display for a variety of possible extra payment levels the amount of interest saved and the payoff date. So that's vague. All right. What does a variety of possible extra payment levels mean? And once again, we have a judgment call to make. Right? The specification is not completely clear about what's the right thing to do here. And this is how it goes. Right? This is how it goes in software every day. Customers come to you. They have completely vague needs, and you ask them to clarify their needs, and they don't. Or they give you contradictory needs, and you have to kind of make a judgment call about what the best thing to do is. And it's possible to guess wrong. And so it's a good idea to design your software so that if you do guess wrong, you can go back and change it. So let's say, just as a straw man proposal, that by a variety of possible extra payment levels, we mean we pay off $100 extra every month, or $300, or $1,000 extra every month. That seems more or less legit. So let's try to write code that actually does that. Before we get on to displaying the results given various possible different extra monthly payments, I want to talk briefly about how we would display some of this information that we've computed so far to the user. Right? So I've added some code up here. After we compute the total interest, I say console.writeLine. Your total interest is, and then I have this little formatting string here. And this means that we are going to you've seen this before. We have in curly braces the number 0, which means that this thing here is going to be replaced with whatever the total interest is. If we put a colon after that and we put a C, you know that formats it as a currency in the currently active globalization info, the currently active culture info. If we put a 2 after that C, then that means round this thing off to 2 decimal places. As we saw earlier, the decimal that it displays is computed out to 28 or 29 decimal points, which is far too much accuracy. You would never want to show something that went down to a trillionth of a trillionth of a penny. And once again, these format strings, how do I know that C2 means this is a currency value formatted according to the current culture and that I want only 2 decimal places after the decimal point? You just have to look those up. There's a lot of them, and there's a lot of documentation for that available on MSDN. Similarly, down here, I'm going to say that the payoff date is some number of months from now, right? So I've worked out the number of months. Recall that this is an integer and this is a decimal. just replace those to make that a little bit more clear. So when will that be? Well, I'm going to say datetime.now, right, which gives me right now. And then I'm going to add some number of months to that. That will give me a date time, that is that many months in the future. And then I'm going to use this custom format string, which means capital MMM means give me the 3-letter month, so Jan, Feb, Mar, and so on. And then the 4 Ys, you'll recall from our episode on formatting date times, means give me the year. And I think I cautioned you then to make sure that these are always capital M's, not small m's. The small m's are the minutes. All right. So now let's consider this question of what are some extra values that we might want to add on to the payments. Right? Well, let's say that there are $100, $300, and $1,000, and I'm going to make an array of these. Right? I'm just going to stick these into an array. This is a nice technique because, like I said before, customers are going to ask you to change this. You yourself might decide that these values aren't quite right. It is very easy to just come in here and say, oh, you know what? I don't really want $300. I want $500, right? Or I want $250, and I want $500. And I want $1,000, and so on. Right? Having stuff in arrays like this that you can just change very quickly, the powerful programming technique. Well, let's change this back to how it was originally, so 100, 300, and 1,000. All right, so what are we going to do? Well, there are all of these extra payment options, right? So for each one of them, what are we going to do? Well, we're going to compute the total interest. So it's a good thing we solved that easier problem. We're going to compute the total interest given a monthly payment plus this extra payment. That'll give us a new interest rate. Similarly, that'll give us a new interest value. Similarly, we'll compute a new number of months this thing will be paid off in by, again, adding the extra payment to the monthly payment. You notice here, these lines were getting a little bit long. If we formatted this all on one line, then it's almost reaching the edge of the screen. It might even go off it if we made some small changes to here. I've mentioned before, it is perfectly legal in C# for you to format your code however you want. It is traditional, if you break up a long line into multiple lines, to indent the second part of the line, right? And to continue to indent it as you go down. It just makes it a little bit more clear to the user that these are not two different statements. This is all one statement. All right. So once we've done that, then we'll say the extra payment of however many dollars reduces the interest by, and then we have the 1 in here, some amount, and the time by, and then we have 2 here, some months. So this is going to be corresponds to 0, corresponds to 1, corresponds to 2. And again, this really did go off the edge of the screen here, so I've broken it up into multiple lines. It's sometimes easier to read if you do it this way, if you have 1, 2, 3 corresponding to 0, 1, 2, like that. Then it would be to have them all on one line like this. But again, C# is a free-form language. You can format it however you want. So let's just step into this code, and we'll see what happens if I type in that I have a $100,000 mortgage, and I have a 5% interest rate, and I have a $2,000 monthly payment. Right? Well, it ran through all of the options here. It printed them out on the console. And it says, well, my total interest is $12,369.21. You'll notice that this is formatted as a currency with 2 decimal places. The payoff date is April 2019, right? So 50 months from now. And you'll notice again that this is formatted as I said I wanted it. I wanted a short date followed by the year, a short month followed by the year. And then we have these 3 options here. An extra payment of $100, again, formatted as a currency with 2 decimal places. Reduces the interest by $671.14 over the lifetime of the loan, and it reduces the time by 2 months. So that's not a whole lot, but it's something. An extra payment of $300 reduces it by $1,813. An extra payment of $1,000 reduces my total interest by $4,481 and reduces the time by 16 months, more than a year. Right? So there you go. We have solved our real-world problem. I now know that were that the state of my mortgage, that if I decided that I could afford an extra high mortgage payment and my bank decided that was okay, that I could pay off this loan early and that I would save a lot of money on interest, or maybe not very much money at all on interest if I only added an extra $100 a month. And that's as far as we're going to go in this course. Now, what else would we want to do to this program? Well, I totally glossed over unit tests, and we saw that had I added some unit tests to some of these methods, we would have found the bugs in them much faster, right? So were I writing real-world code, I would spend a lot more time up front trying to figure out, well, what are all of the different tests that I would want to run on this thing, and try to figure out what some of those scenarios were that we stumbled on earlier, right? So I strongly encourage people to slow down, write code carefully, write a bunch of tests. We would also want to talk to the customer. We would want to show whoever had asked us for this program, the program at an early stage and say, is this really what you want? You know, are these the extra values that you want, or do you maybe want this to be what happens if I increase my payment by 10% or 20% or 30% instead of hard-coded values, right? You might think about what other features are desired. You know, do you want this to write out the entire amortization table, right, that shows over time how the loan decreases, how the principal gets smaller, how the interest rate payments get smaller. So, summing up this episode, I strongly encourage you to write a specification that describes the experience of using the program for the entire program. Even if it's vague, you can always come back and make it more crisp later. Pay particular attention to error recovery scenarios. We've seen that users can and will type in crazy things. You build solutions to complex problems by composing solutions to simpler problems. And if you get nothing else out of this course, you know, even if you do not become a programmer, this is the most important problem-solving technique that we have in mathematics and computer science, is take a big problem, break it down into a bunch of little problems, put all those little solutions together to make a solution to a big problem. Code carefully, think as you're coding, write specifications, write tests as you go, and if you find a bug, fix it by thinking, don't fix it by reflex. Odds are good you're going to introduce another bug if you just try to fix a bug very quickly. In our next video, we're going to take a look at some of the things we didn't cover in this course.